Hobbits and dragons, broomsticks as modes of transport. In our lives, all these are mere fantasy. But what if I told you such things could actually exist? Well, not in our universe, but in alternate universes. But wait, if our universe is everything there is in the cosmos, could matter really exist outside of everything? There are actually three pretty convincing ideas that point to this possibility. The first is eternal inflation. Scientists think that our universe was first formed by an event known as the Big Bang. Then, in the earliest moments of the Big Bang, the universe suddenly expanded in what's called inflation, pushing the cosmos out at crazy speeds. Try turning your radio to an untuned channel. Hear the static? That's actually the radiation thought to be left behind from inflation itself. This provides compelling evidence about the Big Bang theory. And that's not all. If our universe had collided with another one during Big Bang, the CMBR might again provide evidence in the form of radiation patterns, though they haven't been discovered just yet. Also, inflation might not just be a one-time event. They may always be a part of space that's undergoing inflation right now. This means that new universes are always being formed from random fluctuations in space, creating a multiverse. The second piece of evidence is dark energy. The universe is expanding, and you would think that this expansion slows down over time due to gravity. But it doesn't, it's accelerating. If I throw this ball up, it falls back down due to gravity. But if this was a galaxy in space, it will fly away faster and faster, as if some force is pushing it away. We don't know what energy causes this force, so we call it dark energy. Now, dark energy must be a pretty strong force to counteract gravity. But surprisingly, the amount of dark energy present in our universe is this little. Think of the multiverse as a hotel with a billion rooms. To observe dark energy of this amount in our universe wouldn't seem as surprising if every room had some amount of dark energy too. All this dark energy would then total to the predicted amount, though most of these universes wouldn't be habitable as we know it. So now we just have to figure out how the multiverse can be diversified enough such that every possible value of dark energy can be found somewhere. String theory might just provide the answer. In string theory, the properties of matter and particles are determined by how the strings vibrate. To achieve this, extra dimensions of the universe are required, because there are simply too many different ways in which strings can vibrate to act as the different particles. The shapes of these extra dimensions determine the fundamental features of the universe, which in turn determine how the strings vibrate. Calculations have shown that there's a huge number of different possible shapes of dimensions, and this, my friends, now provides the large diversity needed in the multiverse theory. The puzzle is now complete, or is it? Some say that the multiverse explains things we don't understand too conveniently. So does the multiverse truly exist? Well, without hard evidence, we can't say for sure. But perhaps in a few years' time, scientists will have discovered conclusive proof of the multiverse, and only then can we finally get an answer to this strange mystery.